9-3 is graphing rational functions. So a rational function is an equation of the form f of x equals p of x divided by q of x, where p of x and q of x are polynomial functions, and q of x cannot be equal to 0 because we can't divide by 0. Okay? Graphs of rational functions can have breaks in continuity. These breaks can be vertical or horizontal asymptotes. Or a point discontinuity, which are like a hole. All right, so remember, an asymptote is something that gets closer and closer and closer to, but our graph never touches. And then a hole would just be like a hole in our graph. We have an error, something's wrong. Okay, so it says for each equation, determine the equations of the vertical and horizontal asymptotes and the values of x for any holes in the graph. Then graph the function. So we're going to want a calculator to do this. But we got to find some things first. So if you look at the next page in your note packet, it has a whole page about all of these things. Okay, so the first column there talks about points of discontinuity or holes in your graph. So if you take your numerator and denominator and factor them, if there's a common factor between the numerator and the denominator, that's where we get a hole. So for example, x squared plus x minus 6 factors into x plus 3 and x minus 2. There's a common factor of x minus 2, so x cannot be equal to 2. So there's a hole in the graph at x equals 2 based upon the original equation. If you plug 2 back into what you're left with, the x plus 3, then you find that the hole's at 5. All right, so we get holes when we cross factors out. We get a vertical asymptote. Again, that's the line that it gets closer and closer and closer to, but it never touches. And the function is undefined at the line x equals a. So, for example, I can't put a 2 in my denominator for x because then my denominator would be 0, and I can't divide by 0. So my function is undefined at 2, so I have a vertical asymptote at x equals 2. Looks like my line got moved on my copies. Horizontal asymptotes. 3 different cases happen when you have horizontal asymptotes. And it all depends based upon the numerator power and the denominator power. Okay? So if the numerator power is equal to the denominator power, the asymptote is at y equals, remember it's a horizontal line, and it's the ratio of the leading coefficients. So for example, 3x divided by 5x minus 1, they both have a power of 1, so their powers are equal. So the horizontal asymptote is the ratio of those coefficients, so 3/5. Now, if the numerator power is less than the denominator power, like this guy right here, he doesn't have an x on the top, so the denominator has a greater power, the horizontal asymptote will always be at y equals 0. And then finally, if the numerator power is bigger than the denominator power, there is no horizontal asymptote. For example, x squared minus 9 over x plus 3. 2 is a bigger power than 1, so there is no horizontal asymptote in this case. Okay, so let's try some. So look at number 1 there, part A. And we have f of x equals x squared minus 4 over x squared plus 5x plus 6. So the first thing that we want to do is we want to factor both of these. Okay, so I'm going to factor the numerator. That's a difference of squares, so we factors into x plus 2, x minus 2. And then I have a plus and a plus. So I'm going to have a plus and a plus. Multiplies to 6, adds to 5. 3 and 2. Okay, now I'm going to look for common factors. Well, they both have an x plus 2. So my simplified form is x minus 2 over x plus 3. Alright, so first of all, let's talk about a hole. We have a hole in our graph because we factored out a common factor. So x plus 2 equals 0. Move it over. So I can't be equal to negative 2. So I have a hole at x equals negative 2. It can't be negative 2 for the original one, but the hole is at negative 2. So I want to make that as an equal. Okay. Vertical asymptotes. I'm going to abbreviate it and say VA. So vertical asymptote. That's if anything's left in the denominator. So again, that's that middle column. Well, okay, I have x plus 3. Well, x plus 3 is equal to 0 when x is equal to negative 3. Okay, so I'm just gonna vertical asymptote 1, 2, negative 3. Here we go. My graph will never ever touch that point right there. Horizontal asymptote. I'm going to abbreviate it HA. Okay? My power. I have an x squared on top and an x squared on the bottom. So that's the first one. The numerator power is equal to the denominator power. So it's the ratio of the leading coefficients. Right? Well, x squared, 1x squared, and 1x squared. So this guy is at y equals 1. Right? Now I know somewhere at negative 2, wherever my graph is at negative 2, that's where I'm also going to have a hole. Now I'm going to put this guy into my calculator. When you put it into your calculator, you have to be very, very careful that you put A, the original equation in, and you use lots of parentheses. So you can either put it in as a fraction, green and y equals. You can put it in like that, or if you don't, make sure you put the whole numerator in parentheses and the whole denominator in parentheses. In as a fraction just so it looks better. So x squared minus 4 over x squared plus 5x plus 6. Again, you could use parentheses there too. The more parentheses used, the better. All right, let's go with the graph. Oop, that's not good. I want to do a zoom 6. Okay, now if you look at your graph, we know at 3, 1, 2, negative 3, excuse me, negative 3, we should have an asymptote. So see, it kind of gets closer and closer and closer to it and never touches it. We can't see our hole right now. That's because of the pixel sizes of your calculator. So what we're going to do is we're going to go look at our window, and down way at the bottom where it says delta, that triangle means delta x, we're going to change it to 0.1, and then hit graph. Hopefully our hole will show up now. Oh, do you see that? There's our hole in our graph. So now what I'm going to do is I'm going to go over to my table, and I'm going to take these points from my table and put them into my calculator. And as you notice, your table's in fraction form, but that's because I put a fraction into my calculator. So when I entered it, I put it in fraction form. If you don't, you'll see those as decimals. Okay, so a few things. Maybe that's easier to figure out, but why did it say error right there at negative 3? Because that's where my asymptote is. And it says error at negative 2 because that's where my hole is. Okay, so I'm going to look at my graph. He should be up here. I'm going to graph nice pretty points up there, and he should be down here. I'm going to graph whatever points I can, not touching my asymptotes. All right, here we go. That should be easier. All right, so at negative 5, I'm at 3.5. 1, 2, 3.5. At negative 4, I'm at 6. So this guy's going like this. At negative 1, I'm at negative 1.5. And 0, I'm at negative 2/3. 2, I'm at 0. So he's kind of doing something like, whoop, there's my hole, like that. Okay, letter B. Same thing, I'm going to factor what I can. X minus 5 is a factor. This guy's a minus and a minus, so it'll be a minus and a plus. Multiplies to 5, subtracts to give me negative 4, so that would be minus 5 and positive 1. Okay, so I'm crossing out the factor of 5, so I'm left with 1 over x plus 1. Okay, let's just start out with a whole. Did we cross out a factor? Yeah, we sure did. We crossed out x minus 5. So we have a whole at x equals 5. Okay, again, going across your asymptote sheet there, a vertical asymptote. That's any factor you have left in your denominator. Okay, well I have like x plus 1 left. So x is equal to negative 1. Horizontal asymptote. I have a bigger power in my denominator. My bigger power is in my denominator, so my horizontal asymptote is at y equals 0. So he's on the x-axis. Alright, now I'm going to go put this guy in my calculator. X minus 5, putting parentheses all around it, divided by x squared minus 4x minus 5. It's hard to see, but it kind of skipped right there at 5. I'm going to look at my table. So at negative 5, I'm at negative 0.25. Negative 4, I'm at negative 1/3. Negative 3, I'm at negative 1/2. Negative 1, 2, I'm at negative 1. So this guy's going like this. Again, he's getting closer and closer and closer to it, but he's not going to cross it. At positive 1, I'm at 0.5. Positive 2, there's 0.5. I'm at 1/3. I'm at 1/4. I'm at 0.2. There's my whole. Like that. Alright, 2 more. So, first thing we're always going to do is we're just going to factor if we can. Alright, well that numerator, again, is the difference of squares. X plus 2, x minus 2, over x minus 2. Common factors I can cancel, x minus 2. So this guy I'm left with is x plus 2. Like it's just a line. Okay, we're left with just a line. So what we have here is we have a whole. We crossed a factor out. We crossed out x minus 2. So we have a whole at x equals 2. Alright. Vertical asymptote. Do I have anything left in my denominator? Nope, so there's none. Horizontal asymptote. I have a bigger power in my numerator. Numerator has a greater power than my denominator. There's no horizontal asymptote. This guy is just a line with a hole in it. Now, if you want your hole to show up, you have to put the original equation into your calculator. Otherwise, you won't see the hole. So parentheses. X squared minus 4 divided by parentheses x minus 2. There's my line with a hole and positive 2. Start with 2, got 1 over 1, there's my hole. show a circle on your graph, but it makes it easier to see if you put a hole there on your paper. All right, last one. Again, first thing you're going to do is you're always going to factor. Minus and a minus is a minus and a plus. Multiplies to 6, negative 6. Subtracts to give you 1. Negative 1. Alright, so here we go. Holes. We crossed a factor out. We crossed out a factor of x plus 2. So we have a hole at x equals negative 2. Vertical asymptote. We have a factor of x minus 3 left in the bottom. So we have a vertical asymptote at x equals positive 3. Horizontal asymptote. My power is bigger in the denominator. Denominator power is bigger than the numerator power. So your asymptote is at y equals 0. Alright, I'm going to put the original back in my calculator. X plus 2 parentheses divided by parentheses x squared minus x minus 6. See my hole there at negative 2. My asymptotes. I'm going to write that. So I'm going to go to my table. Then you can kind of scroll through and see what's happening. You can also look at your picture. See how it's going like this? There's nothing really good to graph. Just know that at negative 2 you have a hole. It's kind of going like that. So at negative 1, I'm at 0.25. And then let's see. 0, I'm at negative a third. 1, I'm at negative 5. 2, I'm at negative 1. So it's kind of going like this. Just drop some nice points that you can graph. 4, I'm at 1. 5, I'm at 0.5. So it's kind of going like that. And that's how you graph rational expressions.